Welcome to Management 720. Let's continue on with Chapter 2. Here are the learning objectives, and as you can see, it has to do with costs, patterns, equations, and estimation. I would say the overall focus of this chapter is to introduce us to one of the basics of managerial accounting, in that we study costs so that we can use them to help us make decisions. And this particular situation, this particular chapter, we're going to learn how to identify costs and their behavior and use that to our advantage to create a cost estimator. If we've got a set of data, can we derive some sort of formula from that data so that it allows us to calculate or forecast costs in the future? So this chapter is how to predict costs in the future based off of a set of historical data. Our first stop here in learning objective 1 is to first understand some of the behavior of costs, at least from an managerial accountant's point of view. So you can see this chart here. We've got variable costs, fixed costs, mixed costs, step costs, and I have a few sort of basic definitions below. Let's actually try and write these, draw these charts so that we can explain them as we go. Okay, so first let's understand what the graph looks like. We have an x-axis, and this is going to be activity. In other words, activity is what we're doing. It can be miles driven, it can be a number of machine hours, number of labor hours, any sort of thing that changes during our production or during our business. So this is going to be the x-axis. And then y, the y-axis is going to be, in this case, initially is going to be total costs. In other words, as we drive more miles, what are the total costs? As we have more machine hours, what is the total cost, et cetera, et cetera. In other words, we're trying to come up with some sort of relationship between the amount of activity and the total cost involved. So the first one we're going to look at is variable costs. And variable costs are going to be costs that change proportionally with the level of activity. So let's take something basic and easy. Let's say we have a bike shop and we're building bikes. So every time we make a bike, we have to purchase a set of components. And let's just say the wheels. Let's say we've got to spend, $25 on the wheels. So every time we build a bike, we have some additional costs that are focused go into our production. So for the first bike, we may have $25. For the second bike, it's now going to be $50, et cetera, et cetera. If we build 0 bikes, obviously we purchase 0 wheels. And so you can see that the more activity, the more bikes we build, the more wheels we have to buy, and the wheels are our costs. So as the definition of a variable cost is it increases proportionally. In other words, I could take any number out here and divide it by 25, and that's the number of bikes. In other words, if I have $100 of costs, well, we're going to find out that's going to be 4 bikes. The next type of cost is going to be total fixed costs, and its behavior is going to look a little different. If we have a bike shop, a fixed cost is going to be a type of cost that does not change. So this one changes proportionally, and this does not change in relation to activity. So if we have activity here, and this is the number of bikes we're building, well, what sort of thing would not change? What sort of costs would not change? Well, one of the most common examples is rent, right? The landlord does not change the rent depending upon the amount of bikes you build. So if you build 0 bikes, 10 bikes, 100 bikes, the rent is always going to be, say, $1,000 or something like that. So this is Y total costs. And in this case, the total costs are the total fixed costs. Now, we are focusing here on total variable costs and total fixed costs. I'll just put a T here. When we want to look at these same costs, but from a unit situation, in other words, this, you can see, adds up. Every additional bike that we build, we have an additional cost, and so the cumulative cost goes up. But if I were to say, for each bike that I build, this is unit variable cost. For each bike that I build, does the price of the wheels change? Well, in our simplified example here, it does not. So this is unit cost and activity. And so when I build the first bike, the wheels cost $25. When I build the second bike, those set of wheels also cost $25. So when I'm looking at variable cost on a unit perspective, you notice that these two look exactly the same. Total fixed costs and unit variable cost have a similar diagram. Well, let's keep going and talk about what does unit fixed cost mean. That means taking this $1,000 for the rent and dividing it by the number of units we produce. So obviously, if I produce 0 units, that first bike that I build is going to have to bear the weight of all $1,000, right? Now, if I build a second unit, I can divide up the cost, the rent between those two bikes. And then when I build the fifth unit, well, now it's down to $100. And so what we end up having is a sort of non-linear shape. Let me turn this here for a second. That goes out like this. And although it never reaches 0, it gets very close. And this is one of the key takeaways of these charts. The first key takeaway is that total fixed costs behaves like unit variable costs in that they don't change by activity. And the next thing is unit fixed costs decrease as you spread them over more production units. And this is what we call economies of scale. And this is why so many businesses want to get big. It's because they have a certain amount of fixed costs, whether it's rent or it's sort of equipment cost or anything else that could be considered a fixed cost, like taxes or insurance. The way to combat large fixed costs is to spread them out over more and more units. The more units you spread it out, each unit only has to bear a smaller and smaller proportion of the rent or whatever it is. So this is this is why you'll see companies trying to produce at capacity, because the closer to capacity you are, the cheaper per unit cost you will end up having. And the last one, just to kind of keep in with the chart that we have here, are step costs. And this also introduced another concept. And let's take something simple. Let's say this is the activity, the unit cost, or I'm sorry, the total fixed cost. Let's say this is 100 bikes. Let's say this is 200 bikes. And let's say this is 300 bikes. Let's say when we rent a space, that the space is kind of small, and the rent, this is $1,000, this is $2,000, this is $3,000. Let's say that the max amount of bikes that we can produce in this little spot in a month, just because of size restraints, space constraints, is 100 bikes. That once we get over 100 bikes, if we take an order for something over 100 bikes, we need to expand. Maybe we need to use the space next door, and that's another $1,000. So just remember, some of these costs are step costs, in that there's a range, and we're going to investigate the idea of relevant range in just a moment. That there's a range for which these costs behave this way. They're not for every situation. Typically they're over the situation that we're analyzing. And so this means that there are some costs that stay steady over a certain range, and then they step up because the activity level requires an additional amount of fixed costs. So we take these cost behaviors and we want to combine them. Specifically, we want to combine the total variable cost and the total fixed cost, because remember, our objective here is to come up with some tool that allows us to predict costs. We're first analyzing the behavior, then we're going to create the tool. So let's remind ourselves of the two charts that we're looking at. We're looking at total variable costs, which changes with level of activity, and we're looking at total fixed cost. And we can almost say that total manufacturing costs equal the total variable cost plus the total fixed costs. And this is our first step in our equation. So if I wanted to combine these two charts, what it will look like is this. Well, first of all, if I have any sort of activity down here, and I have my total costs here on Y. Well, if I'm, let's say it's something like, rent of 1,000 is my fixed cost, and my variable cost is something like, 5 per unit, right? So if I'm producing 0 units, I'm still going to have the fixed cost. If I'm producing 10 units, I'm going to have the fixed cost plus 5 times 10. So it's going to be a certain amount above. If I have 20 units, it's going to be the fixed cost plus 20 times 5, or 100. In other words, we're still going to have both of the lines. They're just going to be stacked. So this would be the fixed cost area, and this would be the variable cost area. And I could go to any activity and go up and say the fixed cost plus the variable cost would equal some total cost. Now, how do we get about this? Well, one of the ideas about this prediction model is that we're going to believe that costs behave in a linear way, so we can use the equation of a line. And you probably remember the equation of a line is y equals a plus bx. Well, let's put this in terms of our costs. Y is going to be the y-axis. It's going to be the total costs. A is going to be the fixed costs. B is going to be the variable cost times the level of activity. And once we know that, once we know the fixed costs and we know the variable costs, we can take any level of activity and predict the total costs. Now, just here's another picture of the relevant range, just to show you, sometimes when you're buying items, that the first couple of items you'll buy, perhaps you don't have a relationship with the distributor, and so perhaps costs are maybe a little bit more. And then as you go on, maybe costs fall off as you get higher. This particular one shows low fixed costs and a rising costs as you get close to capacity. But the important part is to remember that sometimes at the low end or the high end of activity, the costs do not behave in a linear fashion. And so we're really just focusing on the normal range of activity. If we open a factory, are we normally going to be just making one item, or are we going to normally be at max capacity? No, most of the times we're going to be somewhere in between, and over that particular relevant range, the model holds true because in that relevant range, the costs behave in more or less a linear fashion. Now, there are a couple of other definitions we want to throw in here. So there are a couple of different types of fixed costs. There's ones that you cannot avoid, and we call those committed fixed costs, or sometimes we call those, let me see, what's the other definition? Capacity costs. And those are things like depreciation, property tax, rent. These are the ones that no matter what your level of activity, you're going to have to pay. Now, there are other things that, remember, the definition of fixed cost is something that does not respond to the level of activity. In other words, the dollar amount doesn't go up or down dependent upon the amount of production. So what are some other fixed costs? Well, advertising maybe, or maintenance, or training. But we would call these discretionary, meaning it's possible that the management would choose not to do some of these if they're having a tough time or whatnot. So committed fixed costs are ones are sort of unavoidable. Discretionary, I wouldn't say are avoidable, are but more in line with the definition, are discretionary. They're up to the management whether they do it or not. But they're still considered fixed costs because they do not change in relation to activity. And I guess another name for discretionary is managed fixed costs. So now that we've understood a little bit more about the cost behavior and working towards our tool, which we're going to be focusing on a linear equation, let's look at the three approaches. Now, at the top here, we've got scatter diagram, meaning we can take a bunch of data and just throw it on the chart and just kind of eyeball it. So for example, if someone asks us some number in between, let's take the chart for which I have the data, the middle chart. If someone says, well, how much would 60 be, or how much would 10 be, or even how much would 35 be? You'd probably have an idea without that line there. If you could probably just eyeball it and guess what it is. But depending on how scattered the scatter diagram is, you could or could not maybe have a really good idea of what a forecasted cost would be. So scatter diagram is sort of using your eye to look at it, and of course it benefits from having a closely packed scatter. If it's widely scattered or has some unusual shape, then it's not as useful. And for those of you who have done statistics, and I'm not sure in your course if you do statistics, I imagine you do some sort of quant analysis, and you can use that here. So at the bottom, least squares regression, and the additional good thing about least squares regression is you can allow for multiple variables, so you don't have to have just one variable cost. You can have multiple variable costs and put them into the equation. But what we're going to focus on here is just sort of the simple, tried and true, the linear equation. Now, this particular type of thing is called the high-low model. Some other just things to realize, including in addition to the relevant range as a limitation, is that there are some other ideas or concepts that go along with the cost estimation. One of the ideas is changes in technology, and that could change the proportion or the relationship between the fixed cost and variable cost. I would say the overall trend for business is to increase fixed costs and decrease variable costs. What's an example of that? Well, think of grocery stores. Grocery stores used to have a bunch of variable costs in the form of checkout people. It used to be, you'd have 5 to 6 or 7 checkout lanes all running, and labor is a variable cost. In other words, you're not paying checkout people when they're not working. So what companies thought about was, if we can increase the volume, how can we decrease our variable costs? Well, think about what grocery stores, and a lot of stores, Walmart included, have done. They've put a lot of dollars into having those automated, those self-checkout lanes, right? Think you can have 6 self-checkout lanes, and there's probably just one person attending. Now, in the beginning, whatever you think about whether that's good or bad, that's just an example of companies deciding to put more money into fixed costs, reduce variable costs, and then hope the volume will end up making the total cost less over time. Now, in the case of the checkout lanes, there have been recent problems. If you've been following the news, several stores have closed, several chains of closed stores because there's been a rash of, I guess, thefts, or, someone was telling me about flash mob thefts where people come in and steal stuff all at the same time, and various rules, various laws in different states also make it a little difficult. Another issue with cost estimation is matching activity and costs. For accountants, this is not a big deal, but for managers, this is something that we don't realize. Just remember, when we're measuring X and trying to figure out total costs, sometimes those total costs trickle in. Sometimes the costs aren't known right away. For example, in factory production, insurance and taxes may come at the end of the year. Utilities may be coming at the end of the month, so that it's sometimes a little more difficult than at first glance to figure out what is the actual total cost, because some of these costs kind of come in at different time periods. For example, another one for transportation, your maintenance. How often do you do maintenance? Sometimes it's quite often, but sometimes it's not as often. So when you're trying to figure out what your variable costs for transportation, well, obviously gas is something you can measure sort of in the moment, but other costs could come in to where they are staggered over time, and you need to have a good idea of matching your activity and the total costs. Another issue is when you're starting to do cost accounting is to pick the right type of cost driver. Now, we have just picked, number of bikes built or something like that. But when you get into a little bit more sophisticated cost accounting, you want to pick a cost driver that's a proxy for the overall activity. So, for example, if you've got a labor-intensive process, perhaps you want to pick labor hours, because you figure as labor goes up, probably all the other costs are going to go up alongside of it. If you've got a machine heavy intensive process, then how many hours you've run the machines may be a better cost driver, maybe a better activity, maybe something better to put along the x-axis as far as your prediction tool. And this last this last chart down here is just an example of economies of scales. This is what you're trying to do. So if we just look at that first line, 100 repairs, total costs $3,500, average cost $35. Okay, well, let's stop right there. You can see 100 times 35, the average cost is $3,500. Now, what is the variable cost? The variable cost per repair is $5. So what we don't know from this chart is what is the fixed cost. So if I multiplied 100 times 5, well, that's going to come up to $500. So the total costs are $3,500. The variable costs are $500. So the remainder, what's left, should be $3,500 total cost minus $500 variable cost should be what's the fixed cost, is $3,000. So if it's truly fixed, it should be the same number for all of these different numbers. So if I go down to 200, I'd say 200 times $20, the average cost is $4,000. The variable cost is still $5 per. So 5 times 200 is $1,000. I subtract that from the $4,000. Again, it shows the fixed cost is $3,000. So if the fixed cost is $3,000 for each of these, for 100, 200, 300, 400, and 500 repairs, notice how the average cost goes down. Now you see the variable cost per repair is still $5 per repair. The fixed costs are still $3,000 in total. But you notice that the average cost, as you do more volume, goes down. And of course, think about this. If your average cost goes down, what you charge can also go down. It's a competition issue, right? The more volume you do, the more you can spread out your fixed cost over more units and reduce your average cost. And then once you've reduced your average cost, you can lower your retail price and compete on price. Continuing on with the idea of different ways of looking at costs. So when we're talking about production costs, there are actually 3 different components of manufacturing costs. So from the variable cost, fixed cost point of view, there's total manufacturing costs are variable cost plus fixed costs. A different view of it would be manufacturing costs equal direct materials, direct labor, and manufacturing overhead. And we use that at different points. In other words, remember, the costs are the same numbers throughout, but how you group them together because of what you're trying to solve or what you're trying to predict might be different by different problem. So in some cases, we're going to use the variable cost and fixed cost, which is what this chapter is focused on. This is just reminding you that there are other ways to look at the costs from a different sort of grouping point of view. So one other grouping is manufacturing cost equal direct materials plus direct labor plus manufacturing overhead. A third version is this manufacturing cost hierarchy, and there will be 1 or 2 problems in the homework. And that's based upon, sometimes you can break down the costs by how many costs are attributed for producing each unit, what are the types of costs for producing a batch of units, what are the types of cost at the product level and at the facility level. And sometimes you are asked, the type of question you're asked lends itself to this type of hierarchy. And so this is the chart from the book, and you can see what type of costs are associated with the unit level, the batch level. So, cost of raw materials is for each unit. Equipment setup, in other words, you run a batch. Every time you run a new batch, you might have to redo the equipment setup. Product level, each one has its own branding. Facility level, those are taxes and property taxes and depreciation, that sort of thing. So let me give you an example this is a basic example from one of the questions. Now that I remember, there are two questions. So each batch must be 100 pieces. The chicken is pre-cut, so this has to do with some sort of chicken retail. The chicken is pre-cut and sent to the store in 10-piece bags. Okay, so just right here, 10-piece bags, 100 pieces, that must mean there are 10 bags. Each bag costs $4. So if we go down to the calculation at the bottom, so if we're doing a batch of 100 pieces and we want to know what's the total cost of the batch, the first thing is the chicken itself. There are 10 bags per batch and each bag costs $4. So the chicken in the bags costs $40. Preparing a batch of 100 pieces, well, that's one batch, takes one employee 2 hours. So we have 2 hours of labor for one batch, and that's $8 an hour. So here, the second part of the equation, one employee, it takes 2 hours times $8 an hour, or $16. And then it says each time we run a batch, we have to put new oil in it. So we have $6 for new oil for each batch. So what would be the total cost? So the total costs are going to be the 10 bags of chicken, the 2 hours of labor, and the one jug of oil. And that all of those things go into making up one batch of chicken. So 40 plus 16 plus 6 equals 62. And if I were to divide that by the 100 pieces of chicken, it would be 62 cents. Just a few comments on the homework. Be aware of what the question is. I have seen students get frustrated when they weren't really focused on what part of the process that the question was asking. So we've just gone through how to do the line equation. Sometimes the question is just asking you only figure out the fixed cost, or only figure out the variable cost. Or they may ask you for the entire process, estimate a new cost. So just make sure you focus on what the question is asking for, so that you're not trying to answer a different question than it's asking. I think it's number 13 is a comprehensive question, and I will just make a note here. There are some questions that are just knowledge-based that are multiple choice. There are some calculation questions. When you're doing homework, just remember that there are always a little bit of extra credit built in. You don't have to finish every last question. And so I would suggest try and do the easy questions first, or the ones that you feel like you know, and then ease into the ones that are a little bit tougher. And if you feel like, the comprehensive question is just too much, don't feel like you need to finish every question to still get, max points on the homework. There's always a few extra points built in. There's one other question type in the homework, and it still utilizes everything we know. It's just presented a little bit differently. So let me go over how to do a question that looks like a chart like this. So sometimes you are given a chart that looks like this, and they may ask you, what is the unit fixed cost for production at 20? In other words, what is, this number here? Well, just using everything we've already learned, we can completely fill out this chart. So let's take a look at some of the simpler things. Well, we know the TVC stands for total variable cost, total fixed cost, and then total cost. Well, these two add up, right? So we at least know that number. Now, total fixed cost, remember we want to use some of our learning as far as the charts. If we talk about total fixed costs, remember its chart looks like this. It stays, think of total fixed costs as the rent. Its costs stay the same no matter what the level of activity. So I could go over here and say, well, no matter if I made 10 or 20 items, my total fixed costs are going to be the same. And also the unit variable costs are that way too, although we have not gotten there yet. Well, let's take the total variable costs. And what is the unit variable cost? Well, if the total variable costs are 50 and we made 10 items, well, this is going to be 50 divided by 10, or 5 items. And I can do the same with the total fixed costs. I can take 40 divided by 10 will be 4. So the unit costs here are 9. If I know, and now this is where the unit variable costs. In other words, this is similar to saying, what do the wheel, each time we make a bike, how much do the wheels cost? Well, they don't change in price. Each time we build a bike, the wheels cost $25. Well, each time we build this product, the unit variable cost stays the same. And so if the unit variable costs are 5 and I make 20 of them, well, this is going to be $100 for the total variable costs. And now I have 140. The total fixed cost, now this is like dividing up the rent over more items. So 40 divided by 20 is going to be 2. And so the unit costs here are 7. And this also illustrates the fact that as we produce more, the per unit cost goes down because we're specifically spreading the fixed costs over more units. And so this chart may look kind of daunting at first, but it employs everything that we've already learned. There's nothing new. It's just looking at it in a different way. Okay. That's everything I have for Chapter 2. If you have any questions, please let me know. And any questions in the homework or questions in the concepts, be happy to answer them. Good luck, and thank you.